There are two things specifically I would like you to know. Some of it you know in some ways, but specifically I want to provide some examples for it. One is that inverse function can be used to solve equations. Solve equations when one side is f. Well, if you have a, is it going on? Thank you very much. Thank you very much. So if you have an equation like this, okay, so you have something, some expression in x equals to a number or another expression, you want to solve it. Isolating for x, you can see this in another world, nothing but applying inverse there. So if you apply inverse to both sides of your equation, the key point here is that f inverse of at x is equal to, no, louder. F inverse of evaluated at x is equal to x. They cancel each other in some ways. F inverse reverses what is done by f. So in other words, there we go. We solved it. We solved it for x. Isolated x. This is basically what you do. You each time solve an equation. That's basically what you're doing. I just wanted to point out this and write an example down for this example. F is invertible. F at 1 is 3. F at 2 is 1. Then solve the equation given by f, evaluated that x cubed minus x plus 2 equals to 1. Is that good?
It's a good question.
Yes.
Finish your sentence of solve equations when
Let f be invertible function, so it means that it has an inverse. And then we also know that f at 1 is 3, f at 2 is 1. Okay? Now the question is solve this one. I'll give you 1 minute. I'll give you 1 minute, and you feel free to talk to the person sitting next to you. And at 30 seconds, I will give you a hint so that you can start there. Talking to the friends sitting next to you is very important. That way you're trying to share. Put together your knowledge, see if you can do this example. Okay. The first hint is to get rid of f on the left-hand side, you have to apply f inverse. F inverse applied on f of anything is equal to that anything which you plugged in f inverse of. So that way you get rid of f on the left-hand side and you can try to solve for the x then. Go ahead, now another 20 seconds maybe. Okay, apply F inverse both sides. And F inverse applied on F, they cancel each other. You get whatever was in F, inverse OF. And for the right-hand side, what is F inverse of 1? Yes, please. 2. How did you get that?
I looked at f at 2 is equal to 1, and the inverse is obviously going to be...
Inverse reverses the process. So if F sent 2 to 1, F inverse will send 1 to 2. So this is equal to 2. So we got rid of F without doing anything more. Well, this is an equation. Now I can solve it. This take to the right-hand side cancels. This is equal to 0. You get either x is equal to 0, x is equal to 1, or x is equal to negative 1. Each time you solve an equation, you are trying in some ways to find an inverse of something. And this is an explicit example that shows that. Any questions, any comments? Okay. The second thing application that I want to bring it up is to find range of your given function. If you know your function is invertible, then there is a method that, well, there's a fact basically to find the range of invertible function. If your function has an inverse, then you know this fact, that range of f, for which we don't have yet any uniform way of calculating. So we don't know what to do in general, but this is a method that I want to bring it up. Well, you already know it, but I wanted to make sure that you see it this way. Range of a function is equal to domain of its inverse. Remember, when it comes to the domains, we have few things to check, at least at this level, yes? So changing range to domain of something, knowing that what is that inverse, or that something, will help you to evaluate your domain. This is basically what is taught most of the time for you guys as a method to find range of a function. Yes, please.
True for the vice versa, so just the range of the...
That is also true, yes. So the other way is also true, meaning that the domain of F inverse, range of F inverse is also equal to domain of, yes. But again, so those are basically same statement if you know that inverse of inverse is inverse. Inverse of inverse is the function itself, so that is what has. Okay, let me do this example. Fine, now. Find the range of this function. Go ahead, please. And again, I will give you 1 minute. You're trying to find the range. For that, you first find the inverse of that function, and you know how to find the inverse. Y equal to the expression, solve it for x, then find the domain of the inverse. That's the range you're looking for. Go ahead, please, and start finding the inverse of that, and if you finish that, then you find the domain of the inverse. Go ahead, please. If you're stuck, please talk to the friend sitting next to you. Finding inverse, you start with this. You're trying to reverse the process. In other words, you want to find for a given y, what is the x? So you solve this for x. We had done similar thing last time, so I just proceed with the same idea that I want to multiply this, expand for x, gather all x's. In this case, y times 2x cubed minus 1 is equal to x cubed plus 1. Expand it. 2y x cubed minus y equals to x cubed plus 1. Now, bring one side all the terms that has x. Maybe I should do it over there because that will give me better space. So x, 2x cubed y. There is an x cubed on the right-hand side. I bring it to the left-hand side. And the y in the left-hand side, I take it to the right-hand side. Yeah? OK, so I can factor out x cubed here. And then divide the coefficient to the other side. And, well, I'm looking for x. I found what is x cubed. I take the third cube, or third root of the right-hand side. OK? That is my F inverse. Well, you guys like to write F inverse here at x, replace everything by x. But we discussed last time that mathematically doesn't really matter if I write x here or y here. So this will be the third root of x plus 1 over 2x minus 1. OK? Now that I have F inverse, I will add it here. I am looking for range of F, but I know that that is same thing as domain of F inverse. Domain here is easy. This is odd root, so odd root doesn't introduce any conditions, any restriction. This is fraction. The denominator cannot be 0. So that is all x's in R such that 2x minus 1 is not 0. 2x minus 1 is not 0 is the same thing as saying x is not half. Or I can write it as the interval notation. Any questions? Yes, please.
Matter which way we write the domain, like
Could you please louder?
do we have to use the interval notation or can we write it?
You have to know both notations. And if you're writing a short answer or answering assignment, either one is acceptable. However, in multiple choices, you may see in some question disappears the other one. So you have to know both of them. Yes, please.
Do
we have to write 2x minus 1 can equal 0, or can we do that like aside, like to the side, and just write
This one, it would be nice if I written another line here, more clear. X cannot be half.
Usually what I do is I just write the final answer and just put the side calculations, or the calculations.
So this part somewhere here, if you're careful that it is not very messy there and kind of someone can follow the flow of your proof or equalities, that's good. Okay. So these two applications, in some sort, you already knew these ones and you were using it. I just wanted to make sure that we point these ones out before I move to the inverse trig functions. Okay. Wait a minute. Did we have a contradictory title there? Inverse trig functions. Can anyone remind us what was the condition for functions to have inverse? When does a function have an inverse? Yes, please. When it is 1 to 1. And can you answer all to this question? Is any of the trig functions 1-to-1 function? No. Then why on earth we are trying to find inverse for? It's like the first thing. We cannot. There is no inverse in that general sense. But we can find a remedy for that. For example, let's look at the sine function. Yes? Sine function, if I look carefully, well, this is awfully non-1-to-1. Yes? Every value in the range is taken infinitely many times. Yes? But I can do something. I can restrict my domain. Instead of looking at the whole real line, maybe if I can pick a smaller interval on which my function is 1-to-1 and stick to that new function with that new domain, and then find the inverse. What I mean here is that if you look at one complete period or several periods, those are not 1-to-1. But if I cut this in a half period, from pi over 2, from negative pi over 2 to pi over 2. If I go from negative pi over 2 to pi over 2, then my function sine is 1-to-1, as the important part is that I have to stick to that interval. And when I say inverse function for sine, what I mean is this, is that restrict your domain to a 1-to-1 domain, meaning that it's a domain on which function is, or sine function is 1-to-1. Here, for sine, we pick this one. Well, for cosine, we can play the same game, yes? So the only difference is that if I go from negative pi to pi, negative pi over 2 to pi over 2, I get to trouble because this is not 1-to-1. So I have to change this. Look at the graph of cosine and pick the part that is 1-to-1 on. Okay, I can choose this one to be 0 to pi. What else? Well, I can do the same thing for tan, for cotan, secant, cosecant, but I will write only one more tan. And remember that this is pi over 2, negative pi over 2. There are these vertical asymptotes. And I go from negative pi over 2 open this time to pi over 2 open. Okay, before we move on, can someone summarize why we are picking these specific domains? Can anyone there? Yes, please.
These domains would pass the horizontal line test.
Because these domains will make our function one-to-one, or as you said, it will pass the horizontal line test. But there is also another property on these domains. These are somehow maximal. If you want to, you can, for example, pick smaller intervals here. But this is the largest you can find on the interval for sine to be one-to-one. Bigger question would be, what is special about these intervals? Why didn't I? Well, obviously, for example, here I could not choose 0 to pi, but I could choose pi over 2 to 3 pi over 2. Or from negative 3 pi over 2 to negative 2 pi over 2. Or any interval that starts from odd multiple of pi over 2 would give us a nice thing. What is special about these intervals? Other than, yes, we know that it's making one-to-one, it is largest one. What else makes these ones?
Work with the special triangle.
They're related to special triangles by including 0 to pi over 2. That's right. But is that enough? Anything else? Well, yes, I would like to hear another. Yes? Well, look, this goes from 0 to pi. Oh, I see. For all of them, this will happen. Actually, I'll point it out. But there is nothing special about these intervals. But to be able to move one, we have to fix a convention, fix an interval, and say that, OK, by this book's convention, we are going to use this interval. And these are the intervals, one of the most repeated standard nowadays in the textbooks or in the literature for math for sine inverse, cosine inverse. For tan, also we have almost every time this one. For secant and cosecant, for example, if you look into another textbook, James Stewart's calculus, it has a different interval, one-to-one interval for secant and cosecant than your book. And there are good reasons to choose different ones, but nothing special, just fix one thing and work with that. For our textbook, this is the one we will work with. For secant, cosecant, cotan, you have to check them yourself. You have to understand where are these things happening. Any questions? Any comments? Once that we have these ones, let me then write the definitions of the trig inverse function. So sine inverse of sum x is equal to theta if and only if sine of theta is x. We are reversing that. That's nothing new there. Inverse function reverses. However, if I leave it this way, it is wrong. Unless I say that this theta must be between pi over 2 and pi over 2. Negative pi over 2 and pi over 2. Yes, there are more than one theta which satisfies this thing. If I restrict myself only on this one, then there's one unique one. That is the value of sine inverse. Cosine inverse of x is theta if and only if cosine theta is x. But this time, that theta must be picked from this interval. Okay? Tan inverse, the same way. Nothing new. I'm just talking about the definition of, oh, I should not include pi over 2. I will call these intervals one-to-one interval of sine, cosine, tan, and so on. Yes? But they also give us something important, that if these are the values that gives us the domain of this thing, then range of sine inverse is going to be equal to domain of that, which is range of cosine inverse is 0 to pi. Range of tan inverse is anything between these two. So negative pi over 2. Pi over 2. What about the domain? Domain of sine inverse will be the range of sine. What is range of sine function? What is the range of sine function?
-1 to
-1 to 1. The interval -1 to 1. So I'll write it somewhere here. So domain of sine inverse is from -1. God. Awful. Okay. For cosine, the domain is -1 to 1. For tan, what is range of tan on that interval? What is range of tan on the interval negative pi over 2 to pi over 2? Yes? The whole real line, it goes from negative to positive infinity. So that means that domain of tan inverse is going to be a real line. The whole thing's over there. How about the graph? Well, this is a general knowledge again. When you have a function and you want to find the graph of its inverse, what do you do? How do you find? Yes, please.
Reflected on the y equals x-axis.
Remember, that's true. Remember that when you find f inverse, you're basically swapping x and y. X and y. On the coordinate, on the plane, the Cartesian plane, if you swap x and y, it means that you're finding, it means that you're finding the reflection of your graph with respect to line y equal to x. So in other words, this will go, I'll try to mimic that. This is sine inverse. For this one, I get, I didn't draw it by right thing, scaling, but I'll try to repeat what I see there. This cosine inverse. For tan, see, these lines will reflect it this way, and then you will get something like, this is tan inverse. Yes, please.
tan inverse at the bottom right of that board. Why'd you use circle back brackets instead of square?
Look, tan of pi over 2. Tan of pi over 2. What is the value tan? Not defined because cosine of pi over 2 is 0. So the interval for the one-to-one interval of 10, I can go very close to pi over 2, but I cannot include pi over 2. That is why I'm putting round, meaning that goes all the way close to pi over 2 and negative pi over 2, but we cannot include that. Yes. Yes. Any other questions? Any other comments? Yes, please.
Topic for today, but wondering, would we be doing something where we take regular functions that we would not be able to find the inverse of, and use restricted to a domain?
You're getting some more silent as I get close. Louder so that I can hear. I get closer. What was the question again?
Could we, like, do you know as we just restricted the domain of these trig functions, and that's how we were able to make them invertible? Could we do the same thing with a regular function that traditionally wouldn't be?
Yes. So we actually already did one such function. We already did a function of this form. Remember, y equal to x squared. Yes? This is not invertible, obviously, because it's not one-to-one. But what is root x? Root x is inverse of this when we restrict on the positive side of x. Yes, there are in the higher math, actually, this is always done that way. But you don't need to be worried about that much at the moment. Any other questions? Any other comments? We need to do more examples. We need to do examples and make sure that we cover some good parts of this. Do some examples like this. What is sine inverse of negative root 3 over 2? What is tan inverse of 1 over root 3? What is cosine inverse of half? Go ahead, please. Go ahead. You should be able to do these ones yourself based on the knowledge you have. And I'll give you 1 minute. You work with your friends on these ones. You have 30 seconds left. You remember that you're trying to find the inverse trig function. In other words, you're looking for an angle which gives you that sine or that tan or that cosine. That's why sometimes you see, have you guys seen other way of writing what is sine inverse, cosine inverse, tan inverse? Yes? Arctan, arcsine. The arc there means really the angle of the angle which has this sine. You can see, or you can write arc as well. 20 more seconds. Okay, what is sine inverse of negative root 3 over 2? I see back there someone, yes? Negative pi over 3. Why? You have to check 2 things. 1, that the sine of this guy, sine of negative pi over 3, is this number. The second thing, you should make sure that this is in the interval that we define the sine to be 1-to-1. And this one satisfies both of that. What about tan inverse of 1 over root 3? Come on. Yes, yes, please.
Over 6.
Pi over 6. Sine of pi over 6, 1 over 2 over root 3 over 2 cancel. This is 1 over root 3. And pi over 6, that satisfies the first condition. Tan of pi over 6 is that. But also, I have to make sure that it is in this interval, which is in this interval, so I will leave it like that. And cosine inverse of 1 over 2 is pi over 3. That's the angle which gives us cosine of which is 1 over 2, and it is in that given interval. Yes, please. Pardon?
Find the range every time. For like,
No, okay. You have to make sure that you're working with the right values. If it is not, well, for example, someone can come and say that, well, isn't 4 pi over 3 also an angle whose sine is this number? You go, yes, so you go around in the third quadrant. This has the same sign, but it's not in the interval, so I cannot use that as the value. Okay? Any other questions? Any other comments? Yes, please. Pardon? After class, yes, sure. After class, please drop by. Let us do another example. I love these examples, actually. Okay. Pick one of those two. I'll give you 40 seconds. This is a quick, you have to think it straightforward. It's not one of the special angles. There is something interesting going on there. So at 45 seconds, you should be able to notice that. I'll give you 45 seconds. Work at least on one of these. If you can do 2 of them, that would be even better. Ten seconds left. Okay. Let's focus on the first one. On the first one, we are saying that what is the cosine of the angle the angle is given by this cosine inverse of 1 over 3. I don't know, 1 over 3 is not one of those good numbers. I don't know what is that angle. But there is an easy trick here that happens, and you have to be careful, and you can solve it in general. Can anyone point out that what is, yes, please. Pardon? Isn't that in general that we said earlier today, f(f) inverse of x is equal to x? Or the other way around, doesn't matter. F inverse of of x is x as well. So if you have a function composed by its inverse, I don't need to know how complicated that function is. They will cancel each other. There's only one thing you have to make sure, that the value here is in the domain of f inverse, and the value here is in the domain of f. So whatever we can plug in there, then that is true. 1 over 3, is 1 over 3 in the domain of cosine inverse? Yes. Then that means that cosine and cosine inverse will cancel each other. We don't need to know what are those angles. Actually, this is not easy angle. I cannot give you the value. But I can say that cosine of cosine inverse of 1 over 3 is definitely 1 over 3. Does this make sense? Does it? Yes. Good. How about this one? Well, you just said sine inverse sine cancel. You get this. That is wrong. Incorrect or wrong. What is wrong with this? What didn't I check there carefully? Yes, please.
It's not part of the domain.
7 pi over 5 is not part of the domain that I use to define sine inverse. So this would only make sense if this value is in that domain. So, no, this is not true. Then how am I going to solve it? Yes, please.
Like, put it into the domain by subtraction.
Turn this guy into an angle which has the same sign, but it is in the interval. Look. Seven pi over 5. Can anyone help me which quadrant that should be at? Yes, please? The third quadrant. Why? Because this is 5 pi over 5. Add 2 to that, somewhere here, yes? Now, what other angle is going to have the same sign value? Yes, please. I didn't get that. Tan of that? I don't know how it's going to be related to tan. Look, sine you get from y, yes? The same y, the only other angle that has the same y is this guy here. How much this angle should be? Remember, this was 5 pi over 5. The remaining part here is 2 pi over 5. Well, I take that 2 pi over 5 and generate it in the fourth quadrant. But I have to go backwards, so this will be negative 2 pi over 5. Sine of 7 pi over 5 and sine of negative 2 pi over 5 are the same. So in other words, I can replace this guy with this guy. I replace sine of, I didn't replace the angle with another. I replaced the whole sine because they're different angles, but they have same sign. What other property this guy has that this guy didn't have? Yes? It is in the one-to-one domain of sine. So you have something in the one-to-one domain of sine, sine inverse sine. They will cancel each other, and I get that. Write that down. I would like to start this one. This is an interesting one, and I have only maybe 2 minutes to complete it. This one is very interesting one. You can use double angle formula here and write this is 2 sine of cosine inverse of 0.35 times cosine of cosine inverse of 0.35. Sine 2 theta is 2 sine theta cosine theta. I'm using that formula. Okay? Now, cosine of cosine inverse. Is this value in the domain of cosine inverse? Yes. Yes. Anything between -1 and 1 is always in the domain. So that means that cosine and cosine inverse can cancel each other, and we get this one here for that one. How about sine of cosine inverse? Sorry, I won't be able to. I wish we had time. I'll give you 1 minute. This is a very interesting question here to be investigated. Here, I am looking for sine of theta such that theta is equal to cosine inverse of 0.35. Yes? I'm just opening up that thing. Yeah? When cosine inverse of 0.35 is theta, what does that mean? That means that cosine of theta is equal to 0.35. Doesn't that mean that? Yeah? Remember, you know what is cosine of theta? So you can find sine of theta. Wait, you have to give us the quadrant. If this theta is given by cosine inverse, which quadrant it should be in? Cosine, the 1-to-1 interval for that was 0 to pi. From 0 to pi over 2, it gives you positive value. So this means that theta is in first quadrant. You know one, and you know the quadrant, and then you know all, including cosine. Have a great day. See you all on Wednesday.